Hey everyone, welcome to the UNCW University Learning Center YouTube channel. Today we're looking at integration problems. We're kind of going to stick to the foundational problems, so we're not going to look at U substitution or integration by parts. With that being said though, let's jump on in. This first problem here is the integral of 5x squared minus 8x plus 5 dx. This is your kind of base case problem when it comes to integrals. It's only power rule, and so this is what you continue to try to manipulate all of your other problems to look like. So let's get started here. What is power rule? Well, if you have some variable to a number, then the integral or antiderivative of that is the exponent. You add 1, and then you divide the entire thing by that new exponent. All right, so let's apply that to our problem here. When you approach a problem like this, you want to kind of break it up at each of the pluses or the minuses. So we have 5x squared, and then the next part is minus 8x, and then the next part is plus 5. So starting with this first part, 5x squared, let's add 1 to the exponent, so 5x cubed, and then we divide by that new exponent. So divided by 3. The next part is minus 8x, and there's kind of an implicit 1 right there. So we add 1 to that, and it becomes 2. And then we divide by our new exponent, 2. Lastly, plus 5. If there's no x, that means, x is to the power of 0 if there's no x. So we add 1 to 0, and that just does x to the 1, which makes it just x. You can remember all of that, or you can just remember if it's just a constant, just chain on an x. So it just becomes plus 5x. Now we can simplify this a little bit. However, before I do that, I forgot, and please don't forget, you need to chain on a plus c. This, just like I forget, is the thing that a lot of people forget and can cost you a lot of points on a test or a quiz. So please always, always, always remember, chain on that plus c. Now we can simplify, and this first piece becomes 5/3 x cubed minus 8 divided by 2 gives us 4x squared plus 5x plus c. And that is your final answer. All right, moving on. This next problem, we want to, like I was saying earlier, manipulate it to kind of look like our base case. So how do we do that? Well, first I'm going to have this denominator, I'm going to split it up so that it's under each of my 2 parts up top here. So instead of being under them at the same time, we're going to split it up. So it'll be integral of x squared over x squared plus 4 over x squared dx. The next thing we can do is, because of the sum and difference rule, we can, this little plus sign here, we can split these into 2 different integral problems. So it becomes integral of x squared over x squared dx plus the integral of 4 over x squared dx. Now with each of these, we can simplify them a little bit. And so this first one, anything divided by itself, just becomes 1. So we're really looking at the integral of 1 dx. The second one here, if we have a variable that's to an exponent on the bottom, we can bring it to the top by making the exponent negative. So we're taking something from the denominator, bringing it to the numerator by making the exponent negative. So it becomes 4x to the negative 2, and now everything's on top. Now from here, we can just apply our power rule. So this first one is just a constant. When it's just a constant, we just chain on an x plus, and then this second one, we add 1. So -2 plus 1 becomes 4x to the -1, and then we divide by that new exponent, all over -1, plus c. Don't forget that plus c. So from here, we can simplify that second part a little bit. So x minus 4, and because this x is a -1, I'm going to bring it back down to the bottom to get rid of that negative. So x minus 4 over x plus c. That is your answer for the second one. Last problem here. Let me move this out of the way. Is integral of, in parentheses, 1 plus 3t times t squared. The first thing we have to do here is distribute out this t squared. Once again, we're trying to make it look like our base case, where it's just variable plus variable plus variable. Could be plus a constant, doesn't have to be though. But we don't want this like multiplication that's going on here. So when we distribute out this t squared, we're left with integral of t squared plus 3t squared, t cubed dt. Now, once again, just power rule. So we add 1 here, t cubed, divide by the new exponent, divided by 3, plus 3t to the 4th, divided by 4, and don't forget plus c. Here, there's not much simplifying you can do. You can just kind of pull the constants out in front of the variable if you feel like it. So you could say 1/3 t cubed plus 3/4 t to the 4th plus c, but either one of these is your answer. They're both the same thing. Those are the 3 problems that we're covering today. If you do have any other questions, I highly suggest checking out this website, Math is Fun, Calculus Integration Rules. Very helpful. It shows all of the rules, some that we didn't cover today and some that we did cover today, including all the trig rules, e to an exponent, plus the ones that I mentioned today, sum and difference, and the power rule. So definitely check out that website, and I wish you guys best of luck in all the math that you're doing.